So this is the simulation for the four robot arms and the fuel rods. If my mic cuts out at all, it's because my computers may be struggling a bit. Uh, four fuel rods coming along, each of which, when we get to the proximity sensor, get picked up by the first robot arm, and then gets passed through one by one into the skip at the end. Added multiple here just so you can see all, like each robot moving separately to each other and all communicating. So possibly, I'm not in the thingy, am I? So this, nope. There we go. And I can run this one. So I kind of speed up a little bit, just that we could see it get going. So I got some messages being printed through both on Capellius's side and on the Ross side. So if I could just resize this. So here we just have all the robots communicating with each other using the sort of manager node that I've written. So we have publishers and subscribers going off between the robot and the managers, and then the action server client set up between each manager. So you can see how they print out the different positions with different states and how they're expecting or receiving the fuel rods. And you can see there's a mix of inverse kinematics, like they're picking up the fuel rod, and forward kinematics that have just rotated a single joint in place. And we can see how the first robot has already collected the second fuel rod, while the first one is just being handed over between the second and third. So I just let this run until all four of them end up in the end. Again, so let's take this one for example. This is where the action client sort of sends to the server for the next manager that we're sending a request to pick up a fuel rod, and then the robot 4 here, the action server, receives the request and it's been logged here, and then when it's free we can collect. As we see, it's just been plonked in there. There we go. And here we are. Second and third fuel rods just being dealt with. We will see there's a little bit of issue with inverse kinematics a bit later on with the later fuel rods, how they come through at an angle slightly despite the arm seemingly being at the correct orientation. I'm not really sure why this happened. Maybe it was the simple way of the inverse kinematics implementation. But as we can see, it doesn't really affect the robot's abilities to pass through the fuel rods as such. They're still getting passed through successfully. And if you see there's no more fuel rods left, if there were more, of course, then it wouldn't really affect the performance of the system still, since it's able to passed through forward successfully. And then since there's nothing left, this first robot just goes to its home position. And it just stays there since it has nothing to do anymore. You can also have a little quick look at how these commands for the first robot were received. So command 2 meaning it has a fuel rod to collect, and then command 0 is just the free command. Of course, the middle two robots and the last one actually as well will have another command, command 1, which is to go and collect the fuel rod at the beginning, and then command 2 would be to pass it along. So as you can see, this is just the last fuel rod here. We can go along and have a look. You'll see that the other three already in there. So it just watches last one being put in. So it just pulls out slightly, and then I use a system forward kinematics to put it into a pose just above the skip, and then puts it in. And there, all fuel rods have been successfully deposited. All of them passed through successfully, and the simulation successfully ended. You can see all the communication happening from the different managers. So we can end this. And that showed that the simulation runs successfully using both forward and inverse kinematics, publisher subscribers, and actual server clients.